Trigonometry student. So this one is Mr. Chen again. So welcome back. Happy New Year. So I'm sure you guys want to get ready for the final. So here we go. Here's this final study packet for everybody for Algebra 2 and Trig. So for those who are interested, so please watch this video. Especially for the one that currently taking my class right now. So especially for you to get ready for the final. And we'll go over some of the typical problem, especially the one that possibly is going to be on the final. So we'll go over at least one problem from each set. And for the video, I'll try to divide it into 4 parts. So right now, I'm talking about the first part of the video. And then you'll see part 2, part 3, and part 4. Okay, so part 1. So this one is all a mix of Algebra 2 and Trig. You'll see that in a minute. So the first set of problem is about simplifying, rationalizing the imaginary number. If you see anything like with the I down the bottom, we do know that I is considered square root of -1. Okay, so we'll take a look at that. And let's see, number 3 looks like that one is a little bit difficult. Okay, let me just snip this one and then I'll put it into the new slide so I can get more space to show all the work here. And then number 3, so we do have 5 plus 4i over -5 minus 6i. So let me open up the Active Inspire. So anytime that I deal with the conjugate in the denominator, so that means we need to multiply kind of like the opposite of the conjugate, the binomial. So what we got here is 5 plus 4i all over -5 minus 6i. Again, conjugate, so let's say that we have a plus b for the given binomial. So the conjugate, it's always considered a minus b. So for this one, what I need to do, I just need to multiply by -5 plus 6i, top and the bottom. And then all you need to do, just multiply it out, distribute or FOIL. But the denominator, if you guys do recognize that, a plus b times a minus b, it's always the pattern of the difference of 2 squares. So basically this one using that difference of 2 square pattern, so we do have 25 minus 6i times -6i, then that would be -36i. So negative, positive, so then that would be minus 36i squared. And we do know that I squared is considered -1, because that I, it's considered square root of -1. So the denominator turns out to be 25 plus 36. So 25 plus 36. And then the numerator, so FOIL, so -25. First, outside, so 5 times 6i, then that'll be 36i. Well, excuse me, it's actually 30i. 4i times -5, -20i. And then 4i times 6i, then that'll be -24, positive 24i squared. And then the rest of this numerator, combine the like terms. So we got -25 minus 24, -49. And then 30i minus 20i, then that'll be 10i. Denominator, combine 25 and 36 together, so that turns out to be 61. And then top and the bottom, you want to find out things that can be reduced, if that's reducible. So nothing can be reduced, so basically just keep it like that. Okay, so for number 3. And going back to the packet. And for the next set of problem is finding the area of a triangle. We do know that the way to find the area of a triangle is always half times base times the height. But somehow the height of the triangle is not given from the diagram here. So what we need to do, we need to apply that to SOHCAHTOA. We're making the auxiliary line for the height. So now to look at that, number 6. So number 6 looks like this one is given as an obtuse triangle. Okay, so let's see. Let me snip this one here. Okay, so number 6. So with the given obtuse triangle, so what we can do, we can always make the height, which is perpendicular from the vertex to the base, from point C all the way down to the bottom base, segment AB. So let's say this one's the height. And we do know that this one is 25 degree. Hypotenuse here is 11 because this one's a right triangle. So by using SOHCAHTOA, so we can find out the height. So the height would be considered sine of 25 degree. So that equals h over 11. So it started off with finding the height. So that means the height, it's 11 times sine of 25. And then step 2, you want to find out the base. Well, for those of you guys probably already know that the base, we can use that any side as the base right here. But the base, I want to use that the longest leg here as the base. So AB, I want to use that as the base. In order to find out the measure of the base, so we need to apply the law of sine. So the law of sine, so this one is showing that it's sine of 25 over 11. So that equals sine of this given angle. Well, this angle here, we do know that's a triangle sum theorem, so it's 180 minus 50, because 25 plus 25, then that'd be 50. Then that means angle C would be considered 130. So sine of 130 all over the base. So that means the base is written as B equals, well, let's just cross multiply, sine of 25 times the base equals 11 times sine of 130. Again, this one you have to do that on the calculator to find out the exact value of the height, or the approximation value of the height and the base. So divided by sine of 25, divided by sine of 25. And then we just want to put this all together. So step 3. So based on what you know from geometry, so area of a triangle, 1/2 times the base times the height. So basically just plugging all the expressions together. So 1/2 times the base. So then that'll be 11 times sine of 130 all over sine of 25. And then the height, we do know that's 11 times sine of 25. So one thing that we notice, things that we can cancel here. So sine of 25, sine of 25. Okay. And let's see what else. Things that we can cancel. So 1/2, 11 times 11, 121 times sine of 130. So basically just find out what that is. And then just put it into the calculator. So 1/2 times 0.5 times 121 times sine of 130. Okay, making sure that the mole here, it's using it as degree. So let's just switch that to mole from radian to degree. Okay, so going back to the normal screen. So 1/2, 0.5 times 121 times sine of 120, sine of 130, excuse me. So sine of 130. There you go. So the area of this obtuse triangle, it's about 46.35 square unit. So 46.35. Okay, so square unit. And now let's go back to the instruction. Let's see how many decimal places that we need to round. Round it to the nearest 10, so it's only one decimal place. So this one, I just rounded up to 46.4. And again, there's no unit. Normally, there's no need to put it in. But in case that you're wondering what that is. So square unit. Okay, so now let's go back to the template. And let's see what else that we have. And the next type of problem is about the sequences in series. So determine if the sequence is arithmetic. If that's the arithmetic sequence, so that means find the common difference, the 50-second terms, and the explicit formula. Okay. So let's take a look at that, number 12. So the common difference is pretty obvious. So negative 15 to negative 5. So basically just add 10. And making sure that's consistent with the next two terms. So basically adding 10. So you get 5 for the third term. So 5 plus 10, you'll get 15. So the common difference is just 10. And then find the 52nd term. So find the 52nd term, you need to find the explicit formula first. So in order to get the explicit formula, we do know that it's a sub n equals a sub 1 plus the quantity of n minus 1 times the common difference. So a sub 1 is given already. Whatever the first term that you started off, it's always a sub 1, that's negative 15. And then n is just that the number of terms that we need to find out the value for. And then common difference, it's already given. It's founded already. So this one, it's 10. So the explicit formula, it's considered a sub n equals negative 15 plus 10 times n. So what I'm doing here, distribute, minus 10. So that means a sub n equals negative 15. Negative 15 minus 10, so negative 25. So negative 25 plus 10n. Negative 25 plus 10n. So that's the explicit formula. Common difference. And then once you get all this, so you can find the 52nd term. So basically plug in a number, so 52nd. So that means n is 52. So a sub n, or a sub 52. So that equals negative 25 plus 10 times 52. So negative 25 plus 520. And then subtract 25, so we get 495. Okay, so then that'll be a sub 52. And then the next one, it's about determine the number of n in each arithmetic series. So basically this one giving you the sum. So the quantity here, the parentheses, is giving you the recursive formula for the sequence. So what we need to do, we need to expand it, and then we need to set the sum equals negative 10,000, well, negative 1,095. Okay, so now to look at that, number 13. Okay, so again, I'll put it into the new slide here. Okay, so number 13. Again, copy and paste. So what we already know that the sigma, so that's just the sum of the entire arithmetic series. Started from the first term, k equals 1, so 7. And by the way, binomial, we can always expand it or separate them. So 10, that's just the coefficient. So 10 times the sigma with k equals 1 all the way to the n terms of k. So this whole thing, the total is negative 1,095. So what does mean that 7 with sigma? It's like 7 times n. Well, that means you need to add 7 multiple times. How many times? N times. So 7 times n. So you get the sum. And then this one here, similar. So it's k. It's just like arithmetic series. So start with k equals 1 all the way to the n. So it's like 1 plus 2 plus 3 plus 4 plus 5 all the way to the n term. Okay, so this one can be written as n times n plus 1 over 2. So that equals negative 1,095. And then from here, you want to solve for n. Well, obviously, n is just a variable. So basically what I can do, expand it. So 2 goes into 10 5 times. So 5 times n minus 5n squared. And then negative 5 times n times 1. Negative 5 times n times 1, negative 5n. And we do know that this one, it's a quadratic expressions on the left-hand side. So that means we need to combine them, if that's possible, or just rearrange the order from the greatest power to the least. So negative 5n squared minus 5n plus 7n. I'll combine those n together, so we do have positive 2n. Okay, so plus 2n. So that equals negative 1,095. Again, quadratic form, it's ax squared plus bx plus c equals 0. So we need to bring everything all together. So negative 5n squared plus 2n plus 1,095 equals 0. And now from here, you want to take out 5 or divide it by negative 5. Well, but the thing is that 2 is not divisible by negative 5. So the way that you need to think about this one is by factoring. If that's not factorable, then you have to use the quadratic formula. So keep that in mind, n is always consider a whole number, okay? Because that n is like a number of terms. So first term, second term, third term, and so on and so forth. So the rest of this, you can factor it, or if that's not factorable, so try to use the quadratic formula. Okay, so factoring or quadratic formula. Okay, so now let's see what else. Going back to the packet. Okay, so the next set of the problem here, so it's all about compound interest. So this one is the compound interest continuously. Okay, so now to look at that, number 15. Again, so I'm not going to show you the whole thing. I just want to show you the way to get started with the problem. And also just want to give you the reminder about the formula that you need to know. Okay, so number 15. So Nicole invests $8,804 in the retirement account with a fixed annual interest rate, compound continuously, after 14 years. The balance reaches $15,412,000. Wait, it's actually $15,412.92. So what's the interest rate of the account? Okay, so compound interest, the formula, it's always considered P(e) to the power of RT. So A, which is the final amount. So P, that's just the initial principal, which is $8,804. And then 14 years, that's just the time. So this one's P, this one is the time. And then the balance reached up to $15,412.92. So this one is the final amount. So after you set up the equations, so you want to solve for R. Okay? So 15,412.92. So that equals $8,804 times e to the power of RT. So 14t. And then from here, divided by $8,804. So divide it. And then for those you might be wondering, what about that, the base e? We can always take the natural log on both sides of the quantity. Because that natural log of e, that's just 1. So what's left here is just 14t. Again, the quantity is just the ratios of this two big number. And then eventually you divide that by 14. So you can solve for t. Okay, so identifying the next type of problem. Identifying the center, the radius. So it's the conic section. It's all about the circle. Again, this one is all about completing the square. Identifying the value of h and k, the center, and the radius. Okay, so to look at that, 17. Okay, let me just snip this one. Okay, so again, let me just put it into the new slide. Okay, so 17. So first thing that you want to do, you want to complete this square. So anything that is considered like term, you want to group them together. So x squared minus ax. Okay, so that's all together. And then y squared minus ay. And now for those you might be wondering, what about that 23, the constant? So you want to separate it, so negative 23. And that's something I actually talk about that from the previous video for the conic sections. So one of those chapters in Algebra 2 honors. And the rest of this, you want to complete the square. The way to complete the square is always b over 2 quantity square. So negative a over 2 quantity square. So negative 4 square, 16. The other one is also 16, so we need to add 16 for those two groups. So add 16 here for the x group, and then add 16 for that y group. And then on the right hand side, you need to add 32, because 16 plus 16, then that'll be 32. and then try to factor it. So we do have x minus 4 quantity square, and then y minus 4 quantity square. Negative 23 plus 32, then that would be considered, let's see, subtract, then that'd be 9. Okay, so right here, so the center, so it's 4 comma 4, and then the radius, which is 3. So 4 comma 4, it's all the way up here, so radius 3. So 3 units to the right, 5, 6, 7. 3 units to the left, so 3, 2, 1. 3 units up, 1, 2, 3. 3 units down, 1, 2, 3. And then simply connect the dots with a circle. Just like that. Okay, so now let's see what else. And for those you might be wondering, what about ellipses and hyperbola and also those things? Well, here's the next one. So identifying the center, vertices, co-vertices, the foci. So this one is all about the ellipses. Okay, so we do have 2 different types of ellipses. One is horizontal, the other one is vertical. So if that's horizontal, so that means a squared, it's always underneath that x squared. If a squared goes underneath that y squared, then that means it's vertical. Okay, so let's take a look at that, number 19 or 20. So they're quite similar, so let's do with one of those. Okay, let's do 20. Again, copy and paste. So first thing that you want to do, just like what we did with the circle, you want to group those like terms and then complete the square so we can factor it. So I just want to make this a little bit bigger. Okay, so group the like terms. So we do have x squared plus 4x all together. And then the other one is 16y squared minus 32y. And what about that constant positive 4? So just move that to the right hand side. So that turns out to be negative 4. So now what we got here is x squared plus 4x plus 4. Again, using that magic formula, b over 2 quantity square to complete the square. So 4 over 2 quantity square, 2 square, so it's 4. And then this one, before we complete the square, so you want to take out 16 first. So we got y squared minus 2y. And then complete the square for this one. So negative 2 divided by 2, negative 1, quantity square, so f1. Now I'm going to be very careful with the number that I need to add on the right hand side. So for this one, nothing we took out here, so that means we just add 4. But this one here, looks like we're just adding 1, but it's supposed to be what, 16 times 1. Because 16 is the greatest common factor. So 16 times 1, so that means we're adding 16. So what we got here is factor it. So x squared, well, don't need that square because we want to factor it. So it's x plus 2, quantity square. And then 16 times the quantity of y minus 1 square. So negative 4 plus 4 got canceled. So what's left here is 16. Divide everything by 16. So you got x plus 2, quantity square over 16. And then y minus 1, quantity square over 1. And then 16 over 16, then that's 1. So this one is just a structure of a horizontal ellipse, which is written as x minus h, quantity square over a square, plus y minus k, quantity square over b square, equals 1. So the center of the ellipse is negative 2, 1. Compare and contrast. Find out the value of h and k. So negative 2, 1. Right up here. And then we do know that the major axis, it's 8. Because that a, it's what? 8, the value of a, it's 4. So 2a, then that'll be 8. So that means from the center, we counted 4 units to the right. 1, 2, 3, 4. And then 4 units to the left. So -2 minus 4, -6. And then from the center, 4 units, well, we got the major axis. So the major axis here, the distance from the end point to another end point, so it's 8. Again, this one is just the major axis. And what about the minor axis? The minor axis is about the value of b. And we do know that b squared is 1, so that means b, it's 1. So 2 times b, so 2 times 1, then that'll be 2. So vertically, so this one is 2 units up, and then 2 units down. And simply connect those vertices and co-vertices. And it looks like we need to find out the foci as well. Yeah, the foci. So the way to find out the foci, we need to apply the formula. So c squared equals a squared minus b squared. So a squared, so 16 minus 1, so it's 15. So take the square root, so c equals root 15. So the foci, again, from the center all the way to the left and to the right with root 15 unit. So root 15, what is that about? So here's the approximation you can get. So it's less than square root of 16, but it's greater than square root of 9. So it's right between 3 and 4. But this one is a little bit closer to root 16, so I would say the approximation is about 3.75 or 3.8. So count it 1, 2, 3.8, somewhere around here. 1, 2, 3, 3.8, somewhere over here. So those are the foci. So the way to identify the foci, so we can just say that the value of a, well, which is what? Well, the value of h, so it's -2, so -2 plus root 15, comma, the value of k, 1. And then over here to the left, so -2 minus root 15, the irrational number, nothing we can combine, comma 1. And then the rest of the major axis, the minor axis, you can always stay at the end point with the xy coordinate. Okay. So this one, that's it. So this one is the first part of the video for the final study packet. Algebra 2 and Trig Honors final study packet. So please, either you guys want to rewind or fast forward to the part of the lesson that I just want to get more review. Especially the one that you forget about what to do. So always focus on those areas. Okay, so I'll see you guys next time. So I'll post up the one for part 2, part 3, and part 4 for the packet analysis. Okay, so stay tuned. I'll see you guys next time.